All right, we're going to continue looking at different organic families, and today we're focusing on the aldehydes and the ketones. Now, aldehydes and ketones are two organic families that are very, very, very similar because they both have the same functional group. So, both of them have our carbonyl group, which is basically an oxygen double bonded to a carbon atom. So it looks like this. Where the aldehyde and the ketone differ is that the aldehyde has the carbonyl group on carbon number 1. So it's on a end carbon, whereas a ketone has the carbonyl group on a inside carbon. So again, this is going to be a lesson where the note is already here for you, and I'm just going to speak and talk about the material. So you need to press pause and copy things down and then listen to the lesson. Okay, so just make sure you have this down. Okay, so aldehydes and ketones both have a carbonyl group, but because they differ in the location of the carbonyl group, we have to name them very differently. So when we are naming them, if we have an aldehyde, so shown here, the carbonyl group is on an end carbon, so it's on a carbon that's also bonded to a hydrogen. It gets the name propanal, and that actually should be pretty easy to remember because the entire name of the family is an aldehyde, so it gets an ending al. Okay. So when you see the carbonyl group on a carbon that is an end carbon, it gets the ending Al. We don't have to use any numbers here because the carbon with the carbonyl group is automatically carbon number 1. If we go and we look at the ketone, then the carbonyl group is on an inside carbon, just like we see right here. So this is an end carbon, this is an end carbon, and our carbonyl group is right here on an inside carbon. It gets the ending -one right here. Now again, that should be pretty straightforward to remember because our ketone gets the ending -one. Now, I have two examples here, propanone and pentan-2-one. And they differ because in the propanone, I have a number, or I don't have a number indicating its position. This is because there's only one inside carbon. So in an instance where there is only one inside carbon, which is propanone, we don't need a number. However, in my next example down here, I have 3 possible inside carbons. So you have to indicate position of the carbonyl group with a number, just like you indicate position for everything else we've been talking about. So aldehyde does not need a number because the functional group is on an end carbon, and that's automatically carbon number 1. Ketone needs a number indicating position of the carbonyl group if there's more than one possible position. All right, so let's look at our families. Both aldehydes and ketones are synthesized by an oxidation reaction of an alcohol. So let's look at what this means. So I would maybe copy this down and then listen. All right, so we're going to synthesize an aldehyde from a primary alcohol. Now, we haven't talked about this yet, but a primary alcohol is when the hydroxyl group is on carbon number 1. An aldehyde has to be synthesized from a primary alcohol. If we look, we have propanol here, and I've used the wrong naming, so I need to fix that. All right, I got the name fixed. So we have propan-1-ol here, and I'm showing an oxidation reaction where that propanol becomes a propanal. Oops, that's propanol. So if we notice, we look here, we have our hydroxyl group bonded to a end carbon, has to be an end carbon to become an aldehyde. And in order for this reaction to happen, we have to have an oxidizing agent, which can be any of these substances. So potassium permanganate or dichromate in H2SO4. You need one of these oxidizing agents for this reaction to happen. What ends up happening is this oxygen stays attached to the carbon, but becomes double bonded. And this hydrogen ends up reacting with something in the oxidizing agent, and we make water, HOH. Okay, so the O of this water is going to come from right here. And the other hydrogen from the water is going to come from right here. So maybe I'll actually highlight that for you. So this hydrogen is going to come either one of these. Doesn't really matter because there's rotation on that carbon, if you remember that. Okay. All right. So we make an aldehyde from an oxidization reaction of an alcohol. Now, notice it's not a catalyst here because this oxidizing agent is directly involved in the creation of water. So ketones are actually synthesized the same way, except it's an oxidizing reaction as well, except it has to be on a secondary alcohol. So our primary alcohol was when a primary alcohol was when had to be on carbon number 1. A secondary alcohol is when the OH group has to be on an inside carbon. Okay, so has to be on a carbon bonded to at least another 2 carbons. So I'm just going to write inside carbon here. So the exact same reaction happens. This basically the same oxidization reaction is happening. Oh, I named this wrong again. It's because there's an old system where the numbers go in front. This is propan 2 all here. Sorry. Okay, backtrack. It's exactly the same oxidizing reaction that happens. The 2 hydrogens come to make the water, and the electrons move and create that double bond for the carbonyl group. All right, now let's talk about what this carbonyl group does to the properties of a hydrocarbon. So scroll up here. So physical properties. Now these aldehydes and ketones are going to have lower melting and boiling points than a similarly sized alcohol. This is because that double bonded oxygen creates a slightly polar molecule, but it cannot it can only engage in hydrogen bonding one way. So that oxygen can attract to a hydrogen, a polar hydrogen on another molecule, but because there's no polar partially charged hydrogens, the hydrogen bonding is really, really limited. So we actually say that there's no hydrogen bonding that happens. So it's slightly polar, but it can really only make dipole-dipole. Because of this, it's less soluble than alcohols, but more soluble than alkanes. It's kind of like the ethers. Okay. They're very good solvents as they mix with polar and nonpolar substances. If we look at aldehydes by themselves, the small aldehydes have a strong, unpleasant odor, and larger aldehydes have a really pleasant, flowery odor. Sometimes aldehydes are used in pheromones. Okay, so pause and copy that maybe. Okay. And then for our chemical properties, both the aldehydes and the ketones are combustible. And Our aldehydes, what they can do is they will react with an oxidizing agent to make a carboxylic acid. And both aldehydes and ketones can be reduced back to an alcohol through a hydrogenation reaction. Okay, so that's all I have to talk about for our aldehydes and our ketones. I'm going to have some practice for you posted, but this is not your practice, so don't do this. So again, the best thing to do, this is not right. The best thing to do is to just really practice being able to recognize the organic family that you have and then naming it appropriately based on its functional group.